Okay, so I'm going to go through these notes. Let me open it up in Notability. Back out of here. Okay, so we have that at Joe's on the Beach, single scoop ice cream cones sell for $2.99. And ice cream cakes sell for $24.99. Rosa buys an ice cream cake for her party. She also decides to buy a single scoop for each of her friends. Write a function that can be used to determine the cost, y, so y equals cost, for any number of cones x. Explain the meaning of the terms in your function. Okay, so what is she going to spend? She is going to spend $24.99 on a cake, and then she's going to buy some number of ice cream cones. We don't know how many yet, but each ice cream cone costs $2.99. So I labeled what my x and y were. I'm going to label here, this is the price of cake. And then over here, this is the price per cone. Question B says, sketch a graph that models the problem situation. Explain how you know your graph models the problem. So we don't technically know how to graph in slope-intercept form yet. That's what today is going to teach us. However, yesterday we talked about how we can find x and y intercepts. We're going to go ahead and find our y-intercept first. So my y-intercept, that shows up when x is equal to 0. So we're going to go through and plug that in. So here's my function, y equals $24.99 plus $2.99 times 0. Again, we talked yesterday about how we find that number because this always ends up canceling out. So we get that the y value is equal to $24.99. So my coordinate point is 0, 24.99. So I'm going to go ahead and plot that. 0, 24.95. 99 is probably right about here. I'm going to go ahead and find my x-intercept. And remember that shows up when y equals to 0. So I'm going to say 0 equals 24.99 plus 2.99x. I'm going to try to solve this for x, and you're going to start to notice that it's going to get a little messy. So I get negative 24.99 when I subtract onto both sides. I'm going to divide by 2.99. So negative 24.99 divided by 2.99 gives me negative 8.36. So my x-intercept is negative 3.86. So that's really messy. It's not a nice number. Not to mention, I can't even see the negative x-axis over here. So finding this really is no help for me. So it was good that I found that y-intercept. Now we're going to try and think about other ways around how we can graph this. So if I think about this language here, it's $2.99 per cone. That language, how the y changes for one change in your x, that's more language for slope. So if we're looking at this, I can determine that the slope of my line is $2.99. Again, because I noticed that language of per cone. That's how the y changes for one unit change in the x. So that means my slope of this equation is $2.99. So what that means, we use the letter m to represent slope. I have a vertical change of $2.99 and a horizontal change of 1. So again, if this is my coordinate point, let's go back here. So, okay, this is my coordinate point, 0, 24.99. If my slope is up to 99, that means I take 24.99 and I add 2.99 to it. And that means I'm going to go up to about 27.98 and over 1. I'm going to add another 2.99, which puts me to 30.97, and again, over 1. I'm going to go up another 2.99, and then over 1. So you can see we're starting to build this line. So I'm just going to connect it. So this is an example where I was able to find that y-intercept and plot that point first. However, when I tried to find the x-intercept, it wasn't nice and easy. So I used my knowledge of language for rate of change. I know that that's the same thing as a slope. So then I went ahead and thought about my slope. I have a vertical change of 2.99 and a horizontal change of 1. So from each point, I went up 2.99 over 1, up 2.99 over 1, up 2.99 and over 1. This point looks like it might be a little bit too high, but it's okay. We're estimating a little bit. explain how your graph models the situation, okay? So how do I see what's going on here? I see that the graph is increasing to show that if she buys more cones, she'll pay more money. Okay. How does the total cost increase with the number of cones bought? We just explained that up above. That's our same answer here. So I'm just going to draw an arrow because that means the same thing. How does the total cost increase with the number of cones? As I go across my line, my number of cones is increasing, as is my cost. How does this appear in the function on the graph? The line is increasing. And the slope is a positive number. What is the y-intercept on the graph? So here's my y-intercept. That y-intercept is 0,2499. How does this appear in the function that you wrote? Well, if we look at our equation, where do you see that y-intercept? You're going to start to notice that that constant value that we have is our y-intercept. Whenever I plugged in to search for it and calculated it, it ends up being that same value. So the y-intercept is the constant in the function. So now we have a little bit more knowledge about how to handle an equation that's written in slope-intercept form, okay? That's what we're calling this. So if we come down here, previously, yesterday, as just a side note, we talked about standard form. Standard form meant that both variables were on the same side of the line. Now we're getting into slope-intercept form. Slope-intercept form is written like this. Y is equal to mx plus b. Okay. So slope-intercept form, I know there's a lot of different letters going around. What is key to understanding is that standard form means your x and y are on the same side. Slope-intercept form, you have y equaling the rest of your functions. Okay. So then, thinking about the problem that we just did, your b value, or the constant term in an equation, is always your y-intercept. So we can always see what that number is, write it, plot that point first. In slope-intercept form, you do not have to calculate your y-intercept because, like we just saw, if we did, it ends up equaling that same value that is just the constant term in the equation. And then this value, like we talked about, is our slope. So we like slope-intercept form because although it's easy to calculate the y-intercepts, we can't calculate the x-intercept like we did yesterday, but we don't need to because we can look at the equation, quickly pull out the y-intercept, plot that, and then use the slope to move to our next point. So question 1 says write an equation in slope-intercept form for the line with a slope of 3/4 and a y-intercept of -2. So again, slope-intercept form, y equals mx plus b. In slope-intercept form, you always want to see your y, you always want to see your x. What you're going to do is just substitute in m for your slope, that's 3/4, and b is your y-intercept, it's -2, so we're going to say plus -2. So we can declutter this a little bit. Y equals 3/4 x minus 2, right? Because adding a -2 is the same thing as subtracting. So if my y-intercept is negative, even though my standard form says to have a plus sign, I can just switch it to subtraction. Now we want to graph it. So again, easiest first point to plot, no matter what form you're in, is your y-intercept. My y-intercept here is -2, so we're going to come down to -2, and then we're going to move with the slope. My slope is 3/4, so my vertical change is 3, so 1, 2, 3. My horizontal change is 4, 1, 2, 3, 4. 2 points, connect them, and there you have your graph. Write an equation in slope-intercept form for the line with a slope of -3 and a y-intercept of -8. So again, our basic form, y equals mx plus b. M is your slope. It's telling us that our slope is -3. And it's telling me that the y-intercept is -8. So there's my equation. I'm going to graph it. I have to go to -8 first. 1, 2, 3, 4, 5, 6, 7. Oh, I don't have enough points. So let's make a little note that we're going to scale by 2's. So I have 2, 4, 6, 8. My slope is -3. We like to see slopes as fractions because the top and bottom numbers specifically tell us how to move. So let's rewrite this as over 1 because now I can see that my vertical change is -3. So I'm going to go down 2 and 3 and over 1 and plot the line. And our last example says write an equation in slope-intercept form for the line with a slope of 0 and a y-intercept of 6. So y equals mx plus b. Always your go-to. So y equals your slope times x plus your y-intercept. We can simplify this. Multiplying by 0 goes away. So if your slope is 0, it's always going to be y equals some number. And if you think about what we talked about the other day, when your slopes are 0, you always have horizontal lines. The only way to draw a horizontal line is if you are stuck at the same y value forever. So I'm going to count by 2's again. So I'm going to say scale by 2. So I'm going to say 2, 4, 6. My slope of 0 has to be this horizontal line. So there I have my graph. You can watch the next video and I'm going to walk through these homework problems for you.